According to the 2002 National Electrical Code, the minimum distance between a metal light pole and an overhead power line is 10 feet. This distance is based on several considerations. Firstly, electrical safety, which is to prevent electrical shock or arcing from occurring between the light pole and the power line. Secondly, structural stability, to ensure that the light pole will not collapse or be damaged during high winds or other adverse conditions. The relevant code section is National Electrical Code 2002 Section 225.26. This section states that where luminaire supports are located within 10 feet of electric supply lines exceeding 600 volts nominal, the luminaire support shall be grounded. Now, to apply this to a project where the existing overhead line is 25 kilovolts, which exceeds 600 volts. Therefore, the metal light poles must be kept at least 10 feet away from the power line. To ensure compliance with the National Electrical Code and to provide an additional margin of safety, it is recommended that the metal light poles be kept at least 15 feet away from the existing overhead power line. The distance requirement may vary depending on local regulations or the specific requirements of the power company. It is important to consult with the power company before installing any metal light poles near overhead power lines. The light pole should be properly grounded to prevent electrical shock or arcing. Grounding is a critical safety measure. It provides a low resistance path for fault currents to flow back to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. This minimizes the risk of electrical shock to anyone who might come into contact with the light pole. When a light pole is located near overhead power lines, there is a risk of voltage gradients in the earth surrounding the pole. A voltage gradient is a difference in electrical potential over a distance. If a person were to stand near the light pole during a fault condition, they could be exposed to a dangerous voltage difference between their feet. Proper grounding helps to minimize these voltage gradients and reduce the risk of electric shock. The grounding system typically consists of a grounding electrode, such as a ground rod or ground plate that is buried in the earth. A grounding conductor connects the light pole to the grounding electrode. The grounding conductor must be sized appropriately to carry the maximum fault current that could occur. The National Electrical Code specifies the minimum size of grounding conductors based on the size of the overcurrent protection device. The grounding electrode must have a low resistance to earth. The lower the resistance, the more effectively the grounding system will dissipate fault currents. The National Electrical Code specifies the maximum acceptable resistance to earth for grounding electrodes. The grounding system should be inspected regularly to ensure that it is in good condition and that the resistance to earth is within acceptable limits. If the grounding system is found to be defective, it should be repaired or replaced immediately. In addition to grounding, other safety measures should be taken when installing and maintaining light poles near overhead power lines. Workers should be trained in electrical safety and should use appropriate personal protective equipment, such as rubber gloves and insulated tools. A safe work zone should be established around the light pole to prevent unauthorized personnel from entering the area. The power company should be notified before any work is performed near overhead power lines. The power company may need to energize the power lines or take other precautions to ensure the safety of the workers. The height of the light pole and the distance of the arm extending from the pole are also important factors to consider. The light pole should be tall enough to provide adequate illumination, but it should not be so tall that it poses a hazard to aircraft. The arm extending from the pole should be long enough to position the luminaire over the roadway, but it should not be so long that it creates excessive wind loading on the pole. The design of the light pole should take into account the wind conditions in the area. The pole should be strong enough to withstand the maximum expected wind speeds. The pole should also be designed to minimize the effects of wind-induced vibration. Wind-induced vibration can cause fatigue damage to the pole and can also create noise. The luminaire should be securely attached to the arm. The luminaire should be aimed properly to provide the desired illumination pattern. The luminaire should be shielded to prevent glare. Glare can reduce visibility and can be a safety hazard. The light pole should be located so that it does not obstruct sight lines for drivers or pedestrians. The light pole should be located so that it does not interfere with underground utilities. Before installing a light pole, it is important to check for underground utilities. The light pole should be installed in accordance with all applicable codes and regulations. The installation should be performed by qualified personnel. The light pole should be inspected regularly to ensure that it is in good condition. Any damage or defect should be repaired promptly. The light pole should be maintained in accordance with the manufacturer's instructions. Proper maintenance will extend the life of the light pole and will ensure that it continues to provide safe and reliable illumination. The National Electrical Code is a comprehensive set of standards for electrical safety. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest edition of the National Electrical Code. The National Electrical Code is published by the National Fire Protection Association. The National Fire Protection Association also offers training and certification programs for electrical professionals. The Institute of Electrical and Electronics Engineers is another organization that develops standards for electrical safety. The Institute of Electrical and Electronics Engineers standards cover a wide range of topics, including grounding, wiring, and equipment design. The Occupational Safety and Health Administration is a federal agency that enforces workplace safety regulations. The Occupational Safety and Health Administration regulations cover electrical safety in the workplace. It is important to comply with all applicable Occupational Safety and Health Administration regulations. Electrical safety is a critical concern. By following the recommendations outlined in this video, you can help to ensure the safety of yourself and others. Remember to always consult with qualified professionals and adhere to local codes and regulations when working with electrical systems. Taking these precautions will significantly reduce the risk of electrical hazards and create a safer environment for everyone. To reiterate, the distance requirements mentioned are based on the 2002 National Electrical Code. Always refer to the latest edition of the National Electrical Code in any applicable local codes and regulations for the most current requirements. Furthermore, consulting with the local power company is crucial before commencing any work near overhead power lines. They can provide specific guidance based on their equipment and local conditions. The recommendation of 15 feet as a safe distance is an added precaution. While the National Electrical Code 2002 specifies a minimum of 10 feet in certain situations, increasing that distance provides an extra buffer for safety and helps account for potential variations in conditions or unforeseen circumstances. It's always better to err on the side of caution when dealing with electricity. The grounding of the light poles is not just a recommendation, it is a critical safety requirement. Proper grounding ensures that any fault current is safely diverted to the ground, minimizing the risk of electric shock. The grounding system should be installed and maintained according to the National Electrical Code and other applicable standards. Regular inspections of the grounding system are essential to ensure its continued effectiveness. These inspections should include checking the condition of the grounding electrodes, conductors, and connections. Any signs of corrosion or damage should be addressed immediately. It's also important to measure the resistance to ground to ensure that it is within acceptable limits. If the resistance is too high, it indicates a problem with the grounding system that needs to be corrected. In addition to the physical grounding system, it's also important to consider the potential for induced voltages on the light poles. Overhead power lines can induce voltages on nearby metallic structures, even if there is no direct contact. These induced voltages can be hazardous, especially if the light pole is not properly grounded. Shielding can be used to reduce the amount of induced voltage on the light pole. Shielding involves installing a grounded conductive barrier between the power line and the light pole. This barrier intercepts the electromagnetic field from the power line and diverts it to ground. Surge protection is another important consideration for light poles located near overhead power lines. Lightning strikes and other electrical surges can damage or destroy the electrical components of the light pole, including the luminaire and the control circuitry. Surge protection devices can help to protect these components from damage. Surge protection devices are typically installed at the service entrance of the light pole and at the luminaire. These devices divert surge currents to ground, preventing them from reaching the sensitive electrical components. Regular maintenance of light poles is essential for ensuring their continued safety and reliability. Maintenance should include inspecting the pole for damage such as cracks or corrosion, and repairing any damage that is found. The luminaire should also be inspected and cleaned regularly to ensure that it is providing adequate illumination. The control circuitry should be tested to ensure that it is functioning properly. Any vegetation that is growing near the light pole should be trimmed to prevent it from interfering with the pole or the luminaire. The area around the light pole should be kept clear of debris to prevent it from becoming a fire hazard. Light poles should be inspected and maintained by qualified personnel who are trained in electrical safety. These personnel should be familiar with the National Electrical Code and other applicable standards. They should also be equipped with the proper tools and equipment for performing the work safely. Finally, it's important to remember that electrical safety is everyone's responsibility. If you see something that you think is unsafe, report it to the appropriate authorities. By working together, we can help to prevent electrical accidents and injuries. Always prioritize safety when working with or around electrical equipment. Never take shortcuts or compromise on safety procedures. Electricity is a powerful force, and it should be treated with respect. Remember to consult with qualified professionals and adhere to all applicable codes and regulations to ensure a safe and reliable electrical system. Consider the specific environmental conditions when designing and installing light poles. Factors such as wind speed, ice loading, and soil conditions can all affect the structural integrity of the pole. In areas with high winds, it may be necessary to use stronger poles or to install guy wires to provide additional support. In areas with heavy ice loading, it may be necessary to use poles that are designed to withstand the weight of the ice. In areas with poor soil conditions, it may be necessary to use special foundations to provide adequate support for the pole. The type of luminaire used on the light pole can also affect its safety and performance. Luminaires should be selected based on their efficiency, light output, and light distribution. Luminaires should also be designed to minimize glare and light pollution. The control system for the light pole should be designed to provide reliable and efficient operation. The control system should be able to turn the luminaire on and off automatically based on a schedule or based on the ambient light level. The control system should also be able to dim the luminaire to save energy. Remote monitoring and control capabilities can also be added to the control system. These capabilities allow the light pole to be monitored and controlled remotely, which can be useful for troubleshooting problems or for making adjustments to the lighting schedule. Smart city applications can also be integrated with the light pole control system. These applications can use the light pole as a platform for collecting data and providing services such as traffic monitoring, air quality monitoring, and public Wi-Fi. The design and installation of light poles should be coordinated with other infrastructure projects in the area. This coordination can help to prevent conflicts and ensure that the light poles are integrated seamlessly into the surrounding environment. The aesthetics of the light pole should also be considered. The light pole should be designed to complement the surrounding architecture and landscape. The color and style of the pole should be chosen carefully to create a cohesive and visually appealing environment. Public input should be solicited during the design process. This input can help to ensure that the light poles meet the needs and expectations of the community. Regular public meetings can be held to discuss the design and installation of the light poles. Online surveys can also be used to gather feedback from the public. The design and installation of light poles should be a collaborative process that involves engineers, designers, contractors, and the community. By working together, we can create lighting systems that are safe, efficient, and aesthetically pleasing. Consider using energy-efficient luminaires and control systems. This can save energy and reduce operating costs. Consider using light-emitting diode luminaires, which are more energy efficient than traditional luminaires. Consider using dimming control systems, which can reduce the amount of light output when it is not needed. Consider using occupancy sensors, which can turn the lights off when no one is present. Consider using daylight harvesting systems, which can reduce the amount of artificial light needed during the day. Consider using renewable energy sources, such as solar power, to power the light poles. Consider using smart grid technologies to optimize the operation of the lighting system. Consider using data analytics to track the performance of the lighting system and identify opportunities for improvement. By using these technologies, you can create a lighting system that is both energy efficient and cost effective. Consider the impact of the lighting system on the environment. Use luminaires that minimize light pollution. Use control systems that reduce energy consumption. Use renewable energy sources to power the lighting system. Dispose of used luminaires and other lighting equipment properly. By taking these steps, you can minimize the environmental impact of the lighting system. Light pollution is a growing concern. Light pollution is the excessive or misdirected use of artificial light. Light pollution can have a number of negative impacts, including disrupting wildlife, wasting energy, and obscuring the night sky. To minimize light pollution, use luminaires that direct light downward and shield the light source. Avoid using overly bright luminaires. Use control systems that turn the lights off when they are not needed. Plant trees and shrubs to block stray light. Educate the public about the importance of reducing light pollution. By taking these steps, you can help to protect the night sky and reduce the negative impacts of light pollution. The design and installation of light poles is a complex process that requires careful planning and execution. By following the recommendations outlined in this guide, you can create lighting systems that are safe, efficient, aesthetically pleasing, and environmentally friendly. And always prioritize safety and consult with qualified professionals.